Please remember there are additional resources and things such as code samples at EliTheComputerGuy.com. So if you're watching one of these classes and you need to know what code looks like, or if you need links to the resources that we're using, please go to EliTheComputerGuy.com and take a look at our class posting there. Also, please remember that free to the end user classes are not actually free. It costs me a lot of money to be able to provide this type of content. So if you could click on the donate button and throw in a couple of dollars every month, this will help me be able to continue to provide you this type of material. Welcome back. As you know, I am Eli the Computer Guy, and today's class we're going to be going over try statements in Python. So try statements are going to be one of your most powerful tools that you will be using when you are writing scripts within the Python language. One of the things that you have to be thinking about as a technology professional is basically what types of problems are you trying to solve, and why is the technology that you're currently using the best to solve those particular problems. One of the big issues you have with noobs when they decide that they want to learn programming is they run out into the world and they say, I want to learn all programming. So they want to learn C++, and they want to learn C#, and they want to learn JavaScript, and they want to learn Node, and they want to learn Ruby on Rails, and they want to learn CSS, and they want to learn Python, and they want to learn Dart, and they want to learn Go, and they want to learn Rust, so on and so forth. There are an incredible number of programming languages out there. And one of the things a lot of new coders, new technology professionals do not seem to grasp is that all of these different programming languages, really any product within the technology industry, is used to solve a particular set of problems, right? So CSS is basically there to make websites look pretty. JavaScript was originally created in order to make websites interactive. PHP is used as a back-end programming language to be able to interact with things like databases and be able to dynamically create web pages relatively easily. C# is basically for if you're going to be using a Microsoft stack. So if you have an infrastructure that has Active Directory servers and Exchange servers and all the different Microsoft servers that currently exist, C# is most likely the best language for you to use to be able to use all of the tools within what's called the Microsoft stack. So one of the things you have to be thinking about is when you're learning Python, I'm going to ask you a hard question right now, boys and girls. Why are you learning Python? Whoa, what do you mean? I'm learning to program. Yeah, but why? Why are you learning Python and not JavaScript and not Java and not Rust and not Dart and not Go and not C# and not C++ and all the other languages? Why are you learning Python? Because the important thing to understand about Python, what makes Python very powerful and very useful, is that essentially this is a language that is used to super glue data stores and other people's services together. So back in the day, you go back 10 or 15 years, PHP was like the programming language, right? Basically, when technology professionals, when companies essentially owned all of their own infrastructure, PHP was the way to go. You owned your own database server. You owned your own storage server. You owned all of your systems, and so with PHP you could very easily go through and you could write scripts that could go to your database server, could go to your data stores, could go to all these different places, pull information in, and again be able to dynamically be able to build web applications and web pages, right? That was why PHP was valuable back then. But then we went to what's called the service-oriented architecture world, right? So instead of being focused on servers, right? This is my Exchange server, this is my Active Directory server, this is my Apache or Nginx server. We went to a services world. And in the services world, I did not need to own my server. I just needed an email service. I just needed a message service. I just needed a database service. I didn't need to own the database server. I didn't need to know where the database server was. I didn't need to, be able to go in with my little can of air and spray out the CPU fans or whatever, right? I just needed the service that was provided by somebody's database server. And that's where Python came in. So, somewhere around 2010, Python really took off because when all these companies, the Dropboxes of the world, the Twitters of the world, all these different companies were creating something called APIs, application programming interfaces. They were designing these APIs essentially for Python so that Python could go out and it could interact with Twitter. It could interact with Facebook. It could interact with Dropbox. It could interact with Twilio. It could interact with SendGrid, right? All of these different services that were available, Python was a very good language for being able to go out and communicate with these different services, be it either push out data or pull in data, do something based off of the data that was pulled in, and go on your merry way. And so what Python is very valuable for is this ability to interact with all kinds of different systems. It's not simply that you're getting variable values. It's not simply that you're interacting with a database. It's not simply that you're getting interaction or whatever from users. It's that your code can go out into that wider world and try to grab information and then do things. Python is great for something called IoT, the Internet of Things. Imagine if you have hundreds or thousands or possibly millions of sensors, and then you also have millions of different devices that can do things. Turn on HVAC systems, turn on water systems, turn off water, that type of thing. And imagine if all of this stuff needs to be able to communicate, and then based off of certain events, you need events to be triggered, right? Python is a great programming language to do it because it can communicate with all of these different things. It can communicate with messaging services, the whole 9 yards, and away you go. Well, one of the things you have to be thinking about, right? So if you're used to most programming languages, PHP or whatever else, you have the if-else statements. If this variable is above a value, if this variable is below a value, if somebody is logged in, if somebody is not logged in, blase, 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 do something, right? So if statements, right? And we've dealt with that in previous classes. We've had the if, elif, else statements that we've dealt with. But one of the things to be thinking about is when you're going out and you're interacting with these APIs, when you're interacting with the operating system, when you're interacting with different systems, you need something. You need something that looks a lot like an if-else, right? If this connection occurs or I get a value back, do something else, do something else. You need something that looks a lot like an if-else statement, but isn't quite an if-else statement, right? You need the ability to try. All I want to do is be able to try as a programmer. I want my script to be able to try. I want my script to be able to try to communicate with an API or to some other service. If that attempt works, I want something to occur. And if for some reason the attempt doesn't work, I want something else to occur. And it would be really nice if I could get error messages to tell me what the hell is going on. And so basically, that's what we're going to be talking about today with these try statements. What try statements allow you to do is they allow you to create a statement that says, try to run a command on the operating system. Try to connect to Twilio. Try to connect to a REST API. If it works, do whatever it is. Except if it doesn't work, do something else. And this allows us to manage the entire process of communicating, again, with these disparate resources that are really is what makes Python a very powerful and useful language. And so that's what we're going to be dealing with today. But this is one thing that I really want you to be thinking about, especially if you're a new programmer, right? If you're an old programmer, if you're old school, you know why you're learning Python, keep learning Python. But an important thing to be thinking about, if you're new, you're 17, you're 18, you've been told to code, the future is coding. Learn to code. One of the things I really want you to be thinking about is, why are you learning Python? If the only reason you're learning Python is because it's a coding language, you probably should go out and do some more basic research, again, about what problems are you trying to solve. If you're trying to create iOS applications, learn Swift, right? If you're trying to create multiple different types of mobile applications, learn something like React Native or something like that. Again, if you're trying to do the Microsoft stack, learn C#. If you're just simply trying to build dynamic web pages, maybe PHP is still the answer for you. But that is actually something that you should be thinking about if you're a new programmer, is before you go much farther in the series, just kind of be thinking about, like, why am I learning Python? So for this first lab, you might need to use a little bit of imagination. Now, one of the important things to remember when you're going to be writing Python scripts in the real world, most of the time, these variable values that you're going to be processing are going to be coming from an external source. So a CSV file, somebody exports from an Excel spreadsheet into a comma-separated value file, just a text file where all the values are separated by commas, right? You may go and you may read from that CSV file and then pull the values in from the CSV file in order for something to happen. Again, you may go out and communicate with a database somewhere. Maybe it's a local database, maybe it's a database up in the cloud, pull in values from that database in order to do something. And so one of the questions you have to ask yourself is, what if that process doesn't work? Right? You make your call to the database server and you screwed up the credentials, right? So when you try to authenticate to the database server, your script tries to authenticate to the database server, your credentials are incorrect, and so that fails. What if the database server is just down? Again, something that happens in the real world. Everything is up on the cloud and it works 99.99999% of the time, but 0.000001% of the time it fails. What happens if your script goes to make the call to the database server or something else like that? And again, for whatever reason, it is offline for that fraction of a second while your script is trying to make that communication. Well, this little lab will basically print out the a fail message, if for some reason your variable doesn't exist. So in this particular example here, what we're going to do is we're going to have a variable called message, and message is going to equal hello students. So again, imagine this is getting pulled in from some external thing that we don't really want to worry about today. Now, what we want to do here is we want to try. So we want to try to do something. I want to try to print the value of message. So if message exists with a value, it will print out. Except, so if for some reason message doesn't exist, which sometimes happens, we're going to print out on the screen and it's going to say fail, right? Pretty simple. Try, colon, tab in, print message, or do whatever. If for some reason this cannot occur, except print this or do something else, right? So since I have message and all of this works, I'm going to hit go and we're going to see down here, it printed out hello students, right? So it tried to print hello students and hello students printed. So obviously that works. But again, let's talk about the real world. Let's talk about when somebody fat fingers something, not even fat fingers something. Okay, we got message here. What if somebody just does this? Because this is what happens in the real world, right? You're tippy-tap typing away. You wrote 1,000 lines of perfect code. The problem is you screwed up on one variable value or whatever variable name. So try to print message, right? Instead, except if for some reason you're not able to print that, it'll print out fail. So now when we do that, since message does not exist, we will then get down here and it will print out fail. So it will try to do this. If it cannot do this, we'll go to the except and we'll do whatever we have down here. Now, one of the things that you can do is you can simply do pass, right? So sometimes with this, you're going to need to be thinking about variable values, right? Maybe you want to assign the value that comes into a variable. If for some reason that value doesn't come in, you might want to have the same variable with assigned none or something down here. You might want to do that kind of thing. You might want to print a message out on the screen. Sometimes you just want to pass. You just want to try something. Just try it. And if it works, great. Sometimes if it doesn't work, you don't really care. Pass allows you just to continue on. So we do try, we're going to try to print this. If that doesn't work, we're going to pass. When we do this, we don't really get anything because it just passed, right? So it tried to print message. That obviously does not exist, except it then passes. So we see nothing actually occurs down here. So this is the basic concept with a try statement where we try to do something. If that doesn't work, except we do something else. And again, when we do something else, the option could be just pass where we don't do anything at all. So now that we understand the try component and the except component of a try statement, now let's talk about the finally component. So what the finally component does is after try and except has run, so after everything previously has run, basically at the end, you will run this block of code. So right here, we're going to try to print, hello, your name. And then finally, the script is finished. It'll simply print out that the script is finished. If for some reason you're not able to print out the name, it'll go except there was an error, and then it'll also print the script is finished. So basically, if you have this block of code, and at the end of the block of code, you always want something to occur. So maybe at the end of the block of code, you always want a new record entered into the database, even if there is a failure or something, along those lines. Basically, you can have this finally in order for something to occur whenever, the try statement is finished. So with this, what we're going to have here is we're going to have that input function, like we talked about, I think in our last class. It's going to ask for your name. You're going to put your name in. It will then try to print out hello, what your name is, and then it'll print the script is finished. If for some reason there's a failure of trying to print out hello, your name, it'll print out there was an error, and then it'll also print out the script is finished. So I'm going to run this. Click on the run button over there. Your name. So I'm going to type in, come down here and type in Bob. I'm going to hit enter. Hello, Bob. The script is finished. Right? And so this kind of thing can be useful just from a troubleshooting perspective, just to know when the try statements are completely finished, just to be like, okay, this section of code worked, and this part is done. Then the next part of the script works, and this part is done. Right? So anyway, so hello, Bob. The script is finished. Now, what if I go up here, and again, I just do something stupid. I do name3 instead of namey, nam, right? Again, the kind of stuff that really happens. So what should happen here is it'll ask for the name. I'll give it the name, but then when it tries to print out, it'll fail. So we should get there was an error, and then the script is finished. We're going to hit the run button again. So it's still going to ask me my name because my name is outside of this block. So I'm going to come down here. I'm going to say my name is Tim. It'll then say there was an error, right? So it's going to try to print out hello name, but you misspelled name, so that failed. Since that failed, we are going to go to the except. The except said there was an error, so we get there was an error. And then finally, the script is finished, and the script is finished. And so this is all there is to the finally. So basically, we try to do something. If that doesn't work, we accept, we do something else. And then at the end of all of this, whether it works or whether it doesn't work, we run a final block of code for whatever it is that we're trying to accomplish. Now let's talk about else, right? So we have try, we have accept, we have finally that we just talked about, and now we're going to be adding else. Now this is one of those things that'll make a noob's brain melt just a tiny little bit, but it's gonna be okay, right? If you see this else, what are you thinking about, right? You're used to if-else statements. If, elif, else statements, you're thinking, if this happens, do something else, do something else. When you look at the else here, it's very easy to think that this has something to do with the except, right? Try this, else do something else. That's not how it works. That is completely the opposite of how it works. Else is basically, in this instance, means also. It means and. So with else, what you do here is you try to do something. So we have the same input function. What is your name? Try to print out your name and the else. So if try works, also run else and then go to finally. So basically what's going to happen is this is going to be run. If the try works, you will then also run the else statement and then you'll run the finally statement. If, for some reason, the try statement doesn't work and it gets to the except, there was an error, the else will not run and you'll go to finally. So when you're dealing with else in a try statement, this is an and, this is an also. Once what you're doing has succeeded, what additional things do you want to occur? So we're going to input the name, hello, whatever name that you inputted, if it works. Except, if it doesn't work for some reason, there was an error, else. And I'm happy to meet you. So it'll say, hello, Tim, I'm happy to meet you. And then finally, the script is finished like we did before. So if I go and run this, right? It'll ask me my name. I'll come down here. I will say Sue. Hello, Sue, right? Try. This worked. Else. I'm happy to meet you, right? Because the try worked, the else also runs. And then finally, the script is finished down here, right? That's how that works. Again, if we go up and we fat-fingered something, let's say we put 2 E's for name, I'm going to run this. Again, it's still going to ask me for my name because the input function is before all of this. And so I can come down here and I can say Fred. I can then hit enter. Now we see there was an error, right? Because we hit accept, right? Accept because that doesn't work. There was an error. We skip over the else because it didn't work. And then we get to the finally, the script is finished. So that's basically all there is to else in this. Is else is and. Is else is also. If the try works, what else do you want to occur? So now let's talk about printing out the exception error, right? So you're going to do the try, you're going to do the accept, and many times you're just going to simply write in whatever you want to happen if the try doesn't work. But sometimes you're going to want to know, no, seriously, what the hell happened, right? Especially when you're writing a new bit of code or you're developing a new application or new platform. Sometimes you just quite literally don't fully understand how everything interacts with everything else. And so sometimes you're actually going to need to know what the hell the error really is. Not simply that there was an error, right? Once your program, is solid and you understand how it works and all that kind of thing, you may not need to know exactly what the error is because you already know what it is. But when you're new, sometimes you might be like, yeah, but no, seriously, like what failed? Why was there a failure? And so with the accept, we can use exception. And so we're going to say accept, exception. We're going to say as error. So this gives us an alias. And then we're going to print out what the error is. Right? So with this, name equals input, your name, hello, your name, I'm happy to meet you, the script is finished. The same script that we've been doing before. And again, just to show you how it works, this comes up, and I say Phil, and hello, Phil, I'm happy to meet you, the script is finished, right? We've done that before. But here's the thing, right? What if I forgot to do name, right? For, like I say, we're inputting all these values, we're creating all of these variables, and I forgot to do the name thing, right? So name is not actually ever going to be set. If I run this particular script now, and I hit go, basically what we see, we get the exception as error, since it failed, print error. So name is not defined. So I can go back into my script and I can see the try and I can see name and then I can see what's going on and I go, oh crap, I commented out the name before. That's the problem. That's the issue of what's going on. Or maybe I can do, again, input. Maybe I screwed up my function here somehow. Then when I go to run, basically, we get a name error here. So we do get an error in the script, but then we also get a name error. Name input is not defined. Did you mean input? So that spits out an error that I might be able to use in order to try to troubleshoot my script. And so that's all this is, right? So basically you have the try, the else, the finally. So you do accept, and you do exception as, and then you can call this whatever you want. You could call this Bob, and then you could call this Bob if you wanted. So basically this is an alias. And when we talk about aliases, more or less you can call it whatever you want. Again, there's naming conventions and namespaces and all that kind of stuff you have to be careful about. But basically it doesn't have to be called error. Like a lot of times you'll see in demonstration scripts, it'll actually be E, right? So if I do this, again, the same thing that I did before, accept, exception as E, print E, and again, you'll notice that we get the name is not defined. We get the exact same error. So whatever this is, this can be whatever it is that you want. Basically what you do is you do accept, then you do exception, uppercase E here, exception as whatever the alias you want to be is, and then you can simply print out what the error is when it occurred to try to help you with troubleshooting. Now let's take a moment to talk about built-in exceptions, right? So in this last lab, right, we were able to use exception and we're able to print out whatever error we were running into. So when we do this exception, any error that we run into, whether it's a type error, whether it's a file not found error, any kind of error, that's going to be printed out. But the question becomes, what if you want different code to be triggered based off of different types of errors, right? So basically you're going out, you're grabbing a bunch of data from different places, and depending upon the error that you're running into, you want different events to trigger. Well, one of the cool things with Python is they just have a metric crap ton of what are called built-in exceptions. So built-in exceptions are basically built-in errors, the different types of errors that you can have. And yeah, they've got lots of them, right? If we go down, we can have a buffer error, we can have a lookup error, we can have an attribute error, we can have an end of file error, an import error, an index error, a key error, a memory error, a name error, a not implemented error, an OS error. You get the point. There's just lots and lots and lots of these different errors. And so we can have different code triggered based off of the type of error that you're getting. So maybe if you were not able to open up a file, you want one set of code to be triggered. On the other hand, if you're able to open up the file, but the data in the file isn't the data type that you were expecting, maybe you want something else to trigger, right? And so basically, with these built-in, what are called built-in exceptions, we can do basic things based off of the type of exception. So with here, basically all we're going to be doing is we're going to be opening file.txt. So file.txt says, hello, fellow students. Isn't this class cool? What we're going to be doing is we're going to be opening up this file. We're going to be taking the value from this file, setting it to the data variable. We're going to be closing the file. Then we're using else. So if try works, else, print out the value and data. And then finally, the script is finished, right? This is what is supposed to happen. But if we have different types of errors, we want different things to occur. So if we have a name error, so let's say the variable name is not defined when we do the try, we want a set of code to be able to run if there's an error with the name of the variable. If the file is not found for some reason, we want another snippet of code to run in order to do something because the file does not exist. And then finally, we just have a general exception. So if it's an error, but it's not a name error, and it's not a file not found error, it's just another error, we want that error to be printed out so that we understand what is occurring. So this can be very useful. Again, remember, when we're dealing with Python, right, we're dealing with infrastructure. We're dealing with infrastructure. When you deal with infrastructure, you have a whole bunch of servers doing a whole bunch of different things. And so your Python script most likely is going to be going out, and it is going to be grabbing what other servers are producing. So let's say you have some server that's producing reports every hour. So every hour, it creates a CSV report on sales or whatever else. Your script needs to go out and it needs to grab the file that's created by that other server, pull it in, parse it, do something, right? Well, what happens if your script goes out to grab the report and the report doesn't exist? Right? One of the things you need to be thinking about, right, as a real technology professional is when things in your system fail, how will you know? Right? It is not bad for your system to fail. Let's be completely clear here. Your system will fail. Your system is going to fail a lot. That's just our job, right? But the important thing to be thinking about is how will you know your system will fail? If your system fails and you find out about it and you fix it within an hour or two, hey, no harm, no foul, whatever. That's just another day being a tech professional. Here's the thing. What happens if your system fails and it's 4 months later and you don't realize that it failed? That is when everything can go to hell. So, right? So let's say you have a server that's creating these reports. Your script is supposed to be going and grabbing the report. And then for some reason, that report isn't being created, so you get a file not found error. Within this little snippet of code, you can actually use an API call to something like SendGrid. So SendGrid is an email API service. So basically within this snippet of code, you could say, basically, if file not found, email the administrator that there is a file not found error going on with this script so that the administrator knows what's going on and can fix the problem. Again, one of the big things to be thinking about as a technology professional is something called visibility, right? And what visibility means is that you can see what is going on in your infrastructure. It's not just important to know that your infrastructure is working, because many times you assume it's working when it's not, but you need to be able to see the processes that are occurring and be notified or be able to see when there are problems. So being able to code in for specific errors, this might be a useful thing for you with some kind of notification system or whatever else. So anyways, so with this, we have a file, .txt file. Again, hello fellow students, isn't this class cool? We're going to assign that to file name. Try file equals open, file name R, data equals file read. So basically we're going to read the file that we created. That's going to go into data. Then we're going to close the file. If this works, we're going to print out the data, and we're going to get the script is finished down here. If we get a name error, so accept name error as name error. This is simply an alias here. You could write this as something else. Print what the name error is. Accept file not found error as file error. Again, this is an alias. It can be what you wanted. Print what the file not found error is. Exception. Exception, basically any other exception error as error, and then print that out, and you go through. So right now, we can actually see file.txt. So when I go and I run this, it'll say, hello, fellow students. Isn't this a cool class? The script is finished. So the script worked how it's supposed to. Now again, what about the name error, right? What if we have an issue with names? And so, I don't know. I'm just going to do like file one instead of, file, how it's supposed to be. So when it's going to try to read and it's going to try to close, there will be an issue there. If we try to run this now, we'll get name file is not defined. So I can go back and see where file is in my script. Okay, we got file here, we got file here, we got file here. Oops, we got file one there. That's the issue. So that allows me to see that particular problem. Then what about the file not found? So again, let's say I'm typing out file.txt and instead I do fill.txt instead. So we're not going to have a name error. We should have a file not found error. When I run this, we get error. No such file or directory, fill.txt. I can see that error and go, it's supposed to be file.txt, and I can fix that particular problem. So I can do that, and it should work now. Now, what if I have other errors? What if I have other errors? Let's say if I misspell read. So instead of doing file.read, I do file.re instead, right? So that's not a name error. That's not a file not found error. That should be a different type of error. Again, so when I run this, I get this weird thing. IO text IO wrapper object has no attribute REA, R-E-A, and then the script is finished. So I can go and I can try to figure out, okay, what are they talking about with REA? I can see that and go, oh crap, that's supposed to be read. And so I can use that for the troubleshooting procedure. So this shows you, right, how you can trigger events based off specific built-in errors. And then you can kind of just have a catch-all for any additional error. So again, if you fat finger things, you know what the problem is. So this, again, can be very useful. And what I want you to really be thinking about when you're writing these Python scripts, especially for infrastructure, is again, that idea of visibility. It's not an issue if your system fails. It's gonna fail. It's just gonna fail. Again, a lot of people are like, well, Eli, if you're so smart, why are you doing this online education? If you're so smart, why aren't you in the field doing a startup or whatever? Because I like sleeping through the night. Do you know the last time I got a phone call at midnight? You know, the last time I woke up in the morning expecting to do something really, really fun on my Saturday and ended up spending 14 hours rebuilding a server? It's been a long, long time, right? And that's the reality, right? When you're doing technology, crap will fail. Again, don't get me talking about raids. I hate raids. Thankfully, we are past the age of raids, but everybody was like, oh, if you want your data protected, use a raid. I have seen raids fail in the stupidest damn ways. But anyways, right? That's the thing. Storage is gonna fail. This is gonna fail. All kinds of crap is gonna fail. That's what you get paid for, right? If it worked, and that's what I want you to think about too, is if everything worked the way that Microsoft and the vendors said it was supposed to work, we wouldn't be getting paid, boys and girls. It's always funny. Like you get these tech professionals that get really mad. This is stupid. This is horrible. It's like, yes, and that's why you get paid. As soon as everything works seamlessly, you start eliminating employees, which has been happening in the sysadmin world for the past decade or so. But anyways, the important thing is not that there are not problems and not that there aren't errors, because there simply will be. But it's, do you have visibility when the error occurs and then understanding what the actual error is, right? Even if you have visibility, even if you know an error has occurred, if you don't know what type of error it is, you're still going to have a miserable day, right? If I just get a little email message from my script that said, hey, the script didn't run properly because the file that it's trying to grab does not exist. I'd be like, huh, I wonder what's going on. And then I go to the server that's supposed to be producing the file, and I see that the little power light is off. I'm like, what the hell is this? I open up the side of the case and I see the CPU fan literally cut through the little CPU fan power line. And I go, ah, crap. Guess I gotta go find a CPU or a CPU power line, or I gotta get in there with some electrical tape, which again is something that I've actually done in the real world, right? If I know the event occurred and I'm given a direction about what the problem most likely is, it becomes a very simple issue to troubleshoot and get everything back up online. And that's the type of thing that you really need to be thinking about as a technology professional. So there you go. That was the class on try statements. So again, try statements are very much like the if-else statements we've dealt with in the past that you deal with in other programming languages. But the try statements are basically what these are, is when you're trying to connect to an API, when you're trying to grab a file, when you're trying to get some value out of the operating system, right? Basically, this allows you to try to do something. If that doesn't occur, then do something else. Print out an error, log a problem, send a message, any of those types of things. You do the try. If the try doesn't work, you get the accept. Again, with the accept, you can have built-in exceptions. So you can have different accept statements based off of the different exceptions that you might run into. One of the things that might screw you up a little bit is that else basically means and. It means also. So if the try statement works, also run the else statement, right? That's an important thing to remember. It's not like an if else. So if the try fails, do else. No, it's also. And then finally, basically what that means is that once everything is run, whether it worked or whether it didn't work, this is the final block of code that should run for whatever reason, right? Can be very useful for you. Again, what I want you to be thinking about when you're writing Python scripts going into the future is that idea of visibility. Not simply that you know your script has failed, but that you start to write in the components with your scripts to know what failed so that you can then go and try to solve that problem. That will be very useful for you as you're learning Python, and it'll be even more useful for you in the real world when, again, things will in fact fail. So that's basically all there is for try statements today. As always, I enjoy doing this class and look forward to seeing you on the next one.